Hello everyone, my name is Volodymyr Tymofiiv. I am from Technical University of Košice. I am going to present the topic hydrogen production for improved transportation system as a part of smart cities. Industrial hydrogen production is an integral part of hydrogen energy, the first link in the hydrogen consumption life cycle. The diversity of hydrogen production methods is one of the main advantages of hydrogen energy, as it increases energy security and reduces dependence of certain types of raw materials. Efficient hydrogen production will help successfully by integration the hydrogen infrastructure of the European Smart Cities model, which globally supports the overall improvement of the environment. The rapidly growing demand for hydrogen from refineries and chemical plants in the development of low-cost technologies. The Paris Agreement emphasizes the need to combat global climate change by adapting economies in changing conditions and by increasing the attention paid to this problem. The aim of this agreement in improving the implementation of the Convention, including its objective, is to strengthen the global response to the threat of climate change in the context of sustainable development. In addition to increasing the share of renewable energy sources in the energy balance, the following three areas will play an important role in achieving climate goals: the development of electric batteries, carbon capture, use and storage technologies, and hydrogen energy. Hydrogen use is estimated to potentially reduce up to 51% of global carbon dioxide emissions. Hydrogen as a fuel that doesn't leave a carbon footprint during combustion can be a solution to critical problems for new energy based on renewable energy sources. Hydrogen, a colorless, flammable, odorless, and unsettled vaporous substance that is the least difficult individual from the group of synthetic components. It creates a largest number of mixtures than some other components of the Mendelian table of occasion components. As a component of incalculable carbon components, he is available in all create and plant textures and in oil. Hydrogen molecules are very small, so they can pass through very fine, invisible to the pores in bodies. Hydrogen has the lowest density of all chemical elements. Together with oxygen, it forms an explosive mixture. The interest in hydrogen as a source gas can be explained by its high caloric value, which is at least 4 times higher than coal. Because carbon atoms are not involved in the combustion process, hydrogen is a carbon-free energy gas. In addition, it can be saved, due to properties such as the ability to store hydrogen, its high calorific value, and the absence of CO2 emission from combustion. Hydrogen is attractive for use in various energy sectors. Difference in the understanding of the label. Hydrogen can be classified depending on the source and method of production. And so far the main system of hydrogen classification is coal classification. The earliest method of production hydrogen is to convert coal to gas. Classification converts carbon monoxide, hydrogen, and carbon dioxide from organic carbonation compounds derived from fossil fuels. The majority of hydrogen nowadays comes from natural gas. Its carbon bond and can be separated from using a water-based process known as steam reforming. The basis of the natural gas process of steam reforming is the reaction of methane with water. Blue hydrogen is mostly made from natural gas via steam reforming, which involves combining natural gas with heated water to make steam. Green hydrogen is production from renewable electricity with the help of electrolysis. Water electrolysis is a physical-chemical process in which distillated water decompresses into oxygen and hydrogen by the action of a direct current. Pink is often used for hydrogen gained by electrolysis using nuclear energy. Nuclear energy is a very versatile technology and provides low-carbon electricity that can be used to produce pure hydrogen. At present, almost all hydrogen use is concentrable in industry. The four main uses of hydrogen currently are oil refining, ammonia production, methanol production, and steel production by direct reduction of iron ore. Almost all hydrogen comes from fossil fuels. This current utilization of hydrogen is the premise of numerous parts of the worldwide economy and our regular road planners. Currently, there are technological problems that are preventing widespread adoption of hydrogen in these areas, reducing costs and scaling up. In the long term, it should be technically possible to produce all primary steel with hydrogen, but this will require high amounts of electricity with low carbon content. However, by 2030, hydrogen's use in the various modes of transport is expected to be 8.55 megatons per year. In addition, ammonia is expected to be used as a fuel for ships, and by 2040 about 18 megatons of hydrogen will be needed to make it known. Hydrogen demand in 2020 was 19 megatons. Of this total, hydrogen produced 17 megaton was produced from fossil fuels and 19 megaton as a byproduct in refineries, and 0.5 megaton of hydrogen was produced using electrolyzers. In the future, the share of grey hydrogen from fossil fuels and increase in the share of low-emission blue hydrogen and huge increase green hydrogen are expected. In 2050, hydrogen production by electrolysis should reach 75 nt-megaton and become the leading technology in the hydrogen production market. The price of hydrogen gas is determined by the cost of raw materials and energy, as well as by the method of production. When hydrogen is produced from natural fuels, its cost depends linearly on the cost of the raw materials. In the electrolysis methods of hydrogen production, its price depends on the cost of electricity by 70–80%, which means that the price of hydrogen is affected by the parameters of the electrolyzer and the price of electricity. Gray hydrogen is currently the cheapest option at around €1 per kilogram, but in some regions it's as high as €3 per kilogram. For China and India, which imported most of their gas, coal-based hydrogen is generally the cheapest option. If carbon capture and storage technology is used to convert the cheapest gray hydrogen to blue, this will lead to a cost of around €1.5 per kilogram. Greenhouse gas emissions from hydrogen production differ depending on the technology. Hydrogen produced from fossil fuels doesn't necessarily exhibit the highest CO2 emissions. Using electricity from natural gas or coal for electrolysis can result in a higher CO2 intensity than gray or blue hydrogen due to conversion losses during power generation. If carbon capture using and storage is used, hydrogen derived from natural gas with CCUS represents the lowest CO2 intensity after hydrogen obtained from renewable or nuclear power, and the higher the rate of capture of CCUS, the lower the CO2 intensity of blue hydrogen. Not only how hydrogen is produced, but also whether hydrogen is produced on-site or off-site leads to greatest CO2 emissions, and CO2 is released during the supply, storage and filling of hydrogen. Different modes of hydrogen transport also results in different CO2 emissions. The transport of compressed hydrogen is less carbon intensive than the transport of liquid hydrogen. If we talk about the introduction of hydrogen into the smart city model, then it's worth immediately noticing its several obvious advantages. When used with fuel cells, only water vapor is created instead of various greenhouse gases and microparticles. This feature of hydrogen has huge potential to prevent smoke in car-crowded cities and to prevent CO2 emissions from industry. In addition, hydrogen is a universal energy carrier and a universal energy storage. At the moment, three main sources of energy play the main role in cities: electricity, natural gas, and petroleum products, gasoline or diesel. And just the same, hydrogen can combine these three energy sources or become a link connecting them. For example, it can be used to heat houses instead of natural gas, and fuel cars with it instead of gasoline. That is, to influence those industries where there is not always the possibility of electrification. Also, in the event of a shortage of one of these sources, it will be possible to easily convert part of the electrical energy into hydrogen and increase the share of its use, for example, for heating. Despite all these advantages, Hydrogen also has many disadvantages. The chemical transformation of electricity into hydrogen and from hydrogen back into electricity implies high energy losses, and if we consider the whole chain of production, storage, transport, use, then energy cost will be ever higher. The introduction of a hydrogen economy into the current existing energy mix will not be easy and require many successful solutions to various problems. One of the main problems is how to make hydrogen available to everyone. There should be research and projects on the economies of supplying, selling, and using hydrogen using a digital twin. It's necessary to build the infrastructure necessary for the use of hydrogen. The cost of electrolysis is high. Solutions must be found to reduce this cost in order to pay off this form of hydrogen production. The same goes for other hydrogen-related technologies such as fuel cells, hydrogen storage, and transportation. Hydrogen production technologies are in various stages of development. Some technologies, such as steam methane reforming, are already commercial and can be used in the near future. Others, such as solar thermochemical water splitting, photoelectrochemical, and biochemical, are in the early stages of laboratory development and are considered potential pathways in the long term. The two main markers for hydrogen consumption today are ammonia and methanol production, but in the future hydrogen will be used for different purposes and in different sectors. Hydrogen demand in the oil refined industry is also expected to increase. How 95% of the hydrogen production is used by consumers for their own use, and only 5% of it has been sold commercially on the market. The amount of free hydrogen on the market is likely to increase in the future. Thanks for your attention.